Hello to everyone. Welcome back. We are going to discuss about a unit 2 of AI, general search algorithms, searching for solutions. It is a set A corresponds to the steps required for problem solving. It might have some cost associated with it. One or more nodes can be a part of I set, and every node has a set of successor nodes. A solution path is a path through the graph from I to G. A state space search is the process of searching the state space for a solution to reach the goal. For any problem P, we have a set of initial states, say 1, and a set of goal states, say G. We start with the first state and proceed till either we get a solution or return a failure. If you consider a problem solving agents from general search algorithms, agent is an entity that can perceive the information and act on that information to achieve the desired outcome. Intelligent agent is an agent that is capable of making decisions and act more logically to the scenario. If you consider an AI agent system, it consists of sensors, actuators, and the environment. The environment upon which the sensing element perceives the sensing element is the action is referred as a perception. And the same thing, actuators that responds to the environment referred as actuators or actions. So agents interact with the environment through sensors and actuators. They will perceive the information through the sensor, and actuators allows the agent to take action with reference to the environment that has been perceived. So any human being is an agent who senses the environment through his eyes and nose and then skin, and they will act upon through hand and leg. Problem solving agent examples are the sensory organs or the sensors that perceive the present state and other part of the body, for example, hand, leg, etc., are actuators to help actions. Intelligent car uses sensors such as camera, ultrasonic wave, and other device to measure distance, etc., and some mechanism to apply brake as an actuator based on the sensor perceive information. Automatic attendance system, the fingerprint sensor sends the fingerprint, the actuator gives a message and the attendance is marked for the employee. Automatic door opening and closing system. That is a camera sensor and actuator is to open the door. And general search algorithms control strategies are there are two types of control strategies we have got. One is forward search strategy and a backward search strategy. Forward search strategy is towards a solution. The aim is to reach a solution starting from the initial state. They will start from the initial state and works towards the solution. The methods employs this strategy are often referred to as a data-oriented ones. In this case, you search expedition begins from current position. For example, locating a city from current location in a map. Forward search is exactly opposite, which is nothing but it starts from a goal to a solvable initial state. It could be to a solvable subproblem or a state. Here, the methods employing this strategy are referred to as goal-directed ones. Unlike in forward strategy, if a search begins from target city, it can be termed as a backward search. So, if in between this forward and backward search strategies, there is another strategy that is combination of above two strategies. They are referred as a systematic search. So, systematic search is used when the search space is small and systematic but blind. We can call it as blind because in this case where the search has no information about its domain. The only thing it can do is just distinguishing between the goal and non-goal states. For example, you have to locate a particular book in a library where the books are not indexed and arranged properly. Then there would be no option but to go to blindly and check every book rack. So systematically, you try to cover all book racks. Depth first search and breadth first search are the two most common methods falling in this category. They are also belong to this category of uninformed search. And general search algorithms control strategies. There is another searching technology called as a heuristic search. In this heuristic search, it's typically a technique based on the previous experience and provides guidance to solve the problems. It is a technique that improves the efficiency of a search process. It is exploratory in nature. Imagine a teacher assisting a student in developing some layout of a document. In this process, the teacher may give some important hints to help the students in doing it in the best possible way or may miss some of them. The function of the teacher can be said to have a heuristic approach. Remember that a heuristic search may not find out the best solution, but it guarantees to find a good solution in a reasonable amount of time. It uses some measure of relative metrics which can guide the search. For example, if you are locating a city, air distance of the city from the current location can guide you to select the direction. This approach is most commonly used where the systems have time or space constraints and where the dependency is on the knowledge of the problem domain. So they rely on the promising lines of development to proceed. And if you see the parameters that are involved in a search evaluation, they are completeness, space and time complexity, optimality, and admissibility. So completeness is, we mean that the algorithm finds an answer in some finite time. So the algorithm is said to be complete if it is guaranteed to find a solution if there is one. Space and time complexity, with the space and time complexity, we address the memory required and the time factor in terms of operations that are carried out. Optimality actually tells us how good the solution is. So an algorithm or a search process is said to be optimal if it gives the best solution. About uninformed search methods, we will discuss in the next class. Thank you for watching so far.